Okay, this is chapter 3.4, solving real life problems. And yeah, that means story problems. And some people love story problems and some people hate them. I think the cool thing about story problems is they are real life, and that's the reason we do math. Personally, I just like to do math. Story problems sometimes stump me, and I get into trouble with them. And so I understand anybody who doesn't love them, because sometimes I'm that way too. But this is really the real reason we do math is to solve real life problems. The percent %y in decimal form of battery power remaining X hours after you turn on a laptop computer is this formula. All right, so they're just saying that you turn on your laptop and it's not plugged in, or you turn on your iPad and it's not plugged in, and the battery power, the percentage of life, goes down. If it goes down, you can tell that immediately is going to be what's called a negative slope. Something that's going down is rising in a negative direction and running in a positive direction. And that's just the slope. The battery power is going to go down as time goes by. So time is obviously this bottom. This is the x-axis is our time. And I guess that's X hours. That's why they gave us X. And then they said percent Y. And what we've got here is like in decimal form. So what I want you to think about is that we're going to go up to 100%. And instead of 100% in decimal terms is 1. So instead of 10, we're going to just call this 1. And 90% is 0.9, right? And 80 is 0.8 and so on. So we've got 0.8, we've got 0.6 is 60%, 0.4 is 40%, and so on. If you guys can see that we're kind of rearranging our x-axis so that 100% is up here at the top. Instead of 10, it's 100%, but it's not too much difference. And then we want to remember that a lot of times when we have lines, we're using this y equals mx plus b, this slope-intercept form. And they basically give it to us. They give us y equals negative 0.2x right here. That's the slope, plus 1. So it crosses the y-axis at 1, which is 100%. The decimal form, 100% in decimal form is equal to 1. So that's this point right here. Maybe I should change that color. Would that be more helpful so that we're not seeing the same thing? We use green. Maybe that, I don't know if that'll show up well enough, but we're going to do it anyway. Okay, so it says, and here it says graph the equation. That's what we have to do first. We see that our slope is 0.2 and negative. Okay, now it could be that we just use fractions. Fractions is 0.2 is 2/10. Okay, but since we've got decimals over here, our fractions is don't kill me for doing this, but I'm going to mix my decimals and my fractions. It's over 1. So my run is going to be 1 each time, and my fall is going to be 2/10. So this is 1/10 and this is 2/10. So I'm going to go down 2 and over 1. Hopefully that makes sense. And because it's a real life problem, you sometimes get yourself into these situations where you're using decimals instead of nice easy numbers. But we go down 2 and over 1. And I'm going to just do that. Negative 2 rise, positive 1 run. Negative 2 rise, positive 1 run. Our slope, our rise on the top and our run on the bottom. And we can just see what's happening there. We can just continue all the way down, or we could just try to draw the line starting here. And we can see that we're going to just keep going all the way down. Let's see if to there. Okay, so graph the equation. You just did. Done. A, check. Oops. A. Okay, we graphed the equation. Letter B wants to know something else. It says find the x-intercept, substitute 0 for y in the equation. Now we can see it right here, the x-intercept where it crosses x. But what happens if you substitute 0 for y in the equation? That's this one. I'm going to set 0 is for y is equal to negative 0.2x plus 1. Subtract 1 from both sides. So we get minus 1 and minus 1. So you end up with a negative 1 equals 0.2, negative 0.2. And then you're going to divide both sides by negative 0.2. And what would I do if I wanted to increase this? You can either use a calculator, which is I never recommend, or you can try to figure out how to make negative 1, well, it becomes positive, over 0.2, because they're both negative. Negative over negative is a positive. We just have 1 over 0.2, and we'll just get rid of that so it looks nicer. So x is equal to 1 over 0.2. Well, all I have to do is multiply this by 5/5, and I get 5 over 1, which is equal to 5. So x is equal to 5. So that answers letter B. Letter B, I'm running out of room, guys, sorry. X is equal to 5. And again, I wonder if we can write that better. B, x is equal to 5. I get into a hurry because I know you don't want to watch forever. After how many hours is the battery at 75%? Well, 75% is right here between the 8 and the 7, and so that's right here. About after how many hours is the battery at 75%? Well, that's a hard one to answer, but it looks like if you hit 1 hour, you're at 80%. When you get to 2 hours, you're down to 60%. So 75 is going to be, closer to 1 hour. But we can actually solve that. If you guys will allow me, I'm going to go ahead and make some room. And we'll see what we can do. Alright, so the third part is after how many hours is the battery power at 75%? I'm deleted a little bit of this. 75% is right here. And where does this line cross? Well, it crosses about right there. So what are we going to do? Well, we have to just kind of do the same thing for letter C that we've done for letter B with the y-intercept, except that here we set it equal to 0 because that's when x is 0. But we want to know when when y is 75%, not when y is 0. So we're going to put in 0.75, that's the y, is equal to, at 75% is 0.2x plus 1. Okay, so now we're solving for when 75% happens. And we want to know what x value it is, because that'd be 1 hour, this would be 2 hours, 3 hours, and we know it's kind of close to 1. 1 is up at 80 and 75 is right here. So we're going to subtract 1 from both sides, which gives us 0 over here, but it gives us negative 0.25 is equal to negative 0.2x. And then you're going to divide both sides. This is something that you're accustomed to doing, by 0.2, negative 0.2. And you you don't have to use a calculator for this, but we are going to this time. We want to know what 25% or 0.25 divided by 0.2 is. So we're just going to put in 0.25 divided by 0.2 on a calculator. Google has a calculator, right? Here's our Google calculator. So we're going to go 0.25, which is 25%, divided by 0.2, and we get 1.25. All right, do you see that? Now we're going to run back over here just to look at it real quick at our sketchboard. Okay, so it was 0.25 divided by 0.2 is equal to 1.25. We can check back just to make sure, in case you don't believe me. 0.25 divided by 0.2 is 125, 1 and 25 hundredths. And so that's going to be the answer to letter C. That's the answer to letter C. Okay, so just to be clear, Letter C is answering a question, after how many hours is the battery power at 75%? So this is 1.25. That's 1.25 hours. Okay, so it's a little more than an hour. It's an hour and 15 minutes if you want to know the truth, because 0.25 is a quarter, and a quarter of an hour is 15 minutes. So you get you've lost a little bit in 1.25 hours, and we just need to make sure that we understand what's happening. We could start guessing. Then if we wanted to get down to 50%, we could guess that might be 2.5 hours, and that might mean that it would take us 5 hours, which is what we're showing here, to run completely out of battery down to 0% as we move along the timeline. Okay, have fun with this one.